So this is one such sample. I picked up a sample, a random sample of size 1000 from this population and found a sample mean which came out to be 3.96. If I did this again, I'll get another number. If I did this again, I'll get another number. If I did this again, if I keep on doing this, I'll keep on getting different numbers, right? So all the sample means are different. The idea is to find the mean and the variance of these sample means. So sample mean is a random variable. I want to find the mean and the variance of these sample means, right? So suppose instead of putting this, instead of keeping on doing this, because after a while I'll get, my fingers will all go this, I will write a loop which does this, right? Okay. Now how many times should we do the loop? 10,000 times. Suppose we do the loop 10,000 times. So first I must create a place to keep those 10,000, because I'll get 10,000 sample means. So I must first create a place to keep my 10,000 sample means, right? So what name should I give it? Simple mean. Yeah? C rep 0 I equals 1, repeat, okay, I equals 1, Bombay, the ith column of Bombay gets replaced by the mean of the sample. So this command takes the sample, does that mean and replaces it. I equals I plus 1 if I greater than 10,000 break, right? Sure. So first I'm going to get 10,000 zeros. Timing the camera is an art. Yeah, okay. Right? So I do this 10,000, right? And so this has now taken this 10,000 samples and done this. Okay, now let me write plot density bomb. Okay? Sure? Now you see it's still doing. Yeah, let's take a sample of size 1000. The slow laptop. This is where we go. I think the RAM of this laptop. You see the distribution of the sample mean?
Almost
normal.
Yeah.
Okay. The mean of the population is 4. Sample mean is also 4. And what will be the sample variance? Can you guess what the sample variance will be? So I just ask you to find out variance of Bombay. 0.004. Why is it 0.004? Because the original variance was 4. It is divided by 1000. 4 divided by 1000 is 0.00. I mean, this is almost 4. 0.004. Right? So what you've seen is the central limit theorem at work, right? If you have a population, you have a sample of size 1000, right? Then the sample mean will have the same mean as the population mean. It will be normally distributed approximately, and the variance will be the population variance upon n. Right? Similarly, see, look at this. Variance of x was 4, right? Variance of Bombay 0.0039. Okay, if I change this sample size to 100.
Sorry, I have taken till 10,000 and that.
Yeah, because I am taking 10,000 samples, no? Each of size 100, each of size 1000. Now I am taking 100. See, I is 10,000 because I am going to take a sample of size 1000 10,000 times. Right?
Times number of
Okay.
times.
Now suppose if I do this, what do you think? So let me look at the distribution. Still doing. Slow. I'm not used to such slow computer. You see? It is now a little bit less normal, but the mean is still 4, but the spread has increased. Right? The spread is increased. So you have, for example, if you say variance. So what will be the variance of Bombay? 0.3959 something. Right? Very close to 0.4. Sure? So the first part is of course the consistency part. That is, as the sample size becomes larger, X bar will get closer and closer to the population mean. So the variance of X bar will keep on falling. Sigma square upon n will keep on becoming smaller and smaller and smaller as n becomes larger. That is just a law of large numbers really, we talked about in the first class. We saw that as n becomes large, right? So that's how the law of large numbers really works. But you have a central limit theorem here. Now, so you must now be able to tell me what will be the distribution of, okay, what will be the distribution of, okay, so if you want to tell me, okay, so I create another variable called Chennai, okay, which is Bombay minus 4, which is called Bombay minus 4, let me go back to the sample size of say 1000, yeah, which is Bombay minus 4 upon the square root upon 4 by 1000. What is Chennai? It's a standard normal distribution. Yeah, because it's a normal distribution minus its mean divided by the standard deviation. Right? 4 upon 1000 is the variance of X bar. 4 is the mean of X bar, mean of Bombay. The standard deviation of Bombay is 4 upon 1000. The variance of Bombay is 4 upon 1000. So what did I do? Each value of Bombay minus 4 divided by the standard deviation should be a standard normal. So see that. So plot density Chennai. Yeah? It's a slow computer, so let it.
I didn't understand this Chennai.
What I did was, I just took Bombay. Bombay has mean 4 and variance 4 upon 1000. So we just saw that if you take a normally distributed random variable, subtract out some mean and divide by the standard deviation, you get a standard norm. Mean 0 and standard deviation 1. So I subtracted the mean of Bombay from each value of Bombay.
Yeah.
Bombay minus 4. Divided by this, it would have a variance of 4 upon 1000 because 1000 is sample size, 4 is the original variance.
Right.
So 4 upon 1000 is the original variance.
Yeah.
Square root of that is the standard deviation. So it is Bombay minus 4, a random normally distributed random variable minus its mean divided by standard deviation, which should be a standard normal, right? So let's now plot the. So you see, it's a standard normal, right? Mean 0, right? And if I do what we actually did with it, so for example, if I try to find quantile, okay, find Chennai 0.025, the lowest 2.5% quantile. For the standard normal is minus 1.96. So let's see what quantile we get. Oh, I made a mistake. I should not have said this whole thing. I could have done the last line. I'm sorry for this computer. Because teaching you data science should not be using this slow. Yeah, so minus 1.92, right? Close to minus 1.96. The approximation is only it's only an approximate distribution, right? If I were to increase this, then it will become it will become a much more closer distribution, right? So if I did this, sure, it will become a closer kind of an approximation. So let's now it should take a real long time.
So if population is 1 lakh, then we are taking a sample of 1000, then what is 10,000?
10,000 number of times we are taking a sample of 1000. We are taking 10,000 samples of size 1000. Right? We are taking 10,000 samples of size 1000 because we want the distribution of x bar ना. मैं बटन दबा रहा था अगला आ रहा था ना, तो वैसे मैं ऐसे कितनी बार करूँ, मैं लूप लिखता हूँ 10,000 आने की.
When we will consider the size, we will consider the sample size instead of number of samples.
Number of samples just for the illustration, showing you. I could have made it 10, 20, 30.
Just to get that normal piece.
Yeah, just to get you, just to show you that 10,000 samples लूँगा तो क्या होगा? Just to show you.
So Bombay minus 4 is like the value minus the mean. Bombay minus 4, each element minus
The mean divided by the standard deviation.
So what would be the numerator, like Bombay minus 4, any relevance attached to it?
X bar minus mu, no?
That's variance.
No. Each value of a random variable minus its mean divided by the standard deviation of the standard normal. Right? Okay?
Okay.
Sure?
Standard normal.
Standard normal.
That's a new term.
No, अभी किया ना अपने standard normal. An out-distributed random variable minus its mean divided by the standard deviation n01 किया ना? Right? Okay. Yes, so this is the distribution. Okay? So what you have to do as homework is the basic idea clear?
Yes.
Okay? Right. So please take some sums. And last week's assignments you have handed over? Please do it.
So the videos were not available, so we wanted
Of the video? Okay. So we'll put it up.
That's the like basic material we refer to, study material as of now.
Okay. So I'll excuse you the last week's assignment.
Thank you, sir.
Yeah?
Thank you.
This week. Alright, so I'm going to show you. Yeah. First, write the R code to demonstrate the central limit theorem. Yeah? Write the R code to demonstrate the central limit theorem. 2. Yeah? X100 is a sample from a population with mean 6 and variance 10. Huh? Then describe the distribution of x bar. Okay? Describe the distribution of x bar. 3. What do you mean by the term standard normal distribution. What do you mean by the term standard normal distribution? What is standard and what is standard in the standard normal distribution? Why do you think is the word standard there?
Mu is same and maybe it's
Mean and
Yeah, so why is the word standard there?
because
mean
the
is
scaling.
standardized to 0.
Yeah, so you have to write that properly. Okay? Yeah, it's an assignment. Yeah, standard, right? You have to argue why is the standard normal distribution. Right? Okay? And finally, find the following. Fourth, find the following. One, let X be normally distributed with mean 5 and say standard deviation 6. Yeah? Find X star such that probability X less than equal to X star is equal to 0.03. So basically, this distribution, where will you draw the line on the x-axis?
So 5 is the mean and 6 is the variance?
Standard deviation. In the RNorm command is standard deviation 6, right?
Oh, this symbol is N or what?
belongs to.
Normally distributed. It's a normally distributed, isn't it? N normally. It's a distribution.
Find X.
Find X star such that probability that X less than X star is 0.03. That is where will you draw the line so that 0.03% of the distribution to the left of.
Less and equal to.
Yeah, less than or equal to. A. B. Find (32nd) quantile of X. That is, find the value such that 32% of the distribution of is to the left of that value. Find the value such that 32% distribution is to the left of that value. Right? Find the 32nd quantile of X. C. Find X star such that probability X greater than or equal to X star is 0.07 or say 0.15. Find X star so that probability that X is greater than or equal to X star is 0.15. Yeah?
So how to find code list in this?
How to?
Code list.
There is no code list.
How will you?
So what we will do? Actually, it's quite a straightforward thing. No?
Like apply.
Applying, yes. So just go to, when you want to draw a line, these commands will be enough for you. Yeah. And if you want to how to draw a line in R, go to Google, you will find all sorts of things.
Let X be normally distributed, so
With mean 5, standard
so
deviation
that
6.
means I can define X as a sample size. It could be 1,000, 100.
Yeah, so you have to do R norm.
Or
R norm, some very large number of X.
600.
So to generate randomly distributed random number using the R norm. So basically, to generate these X's, so you have to do like this.
We cannot save as a file.
What?
This
You can, this graph?
this program.
Yeah. Now because I have closed it without asking you, but if I am here, right, I can easily say, if I am closing this, this will actually ask me. You have to save the changes. So wherever you save this, you will save it as a price. Right, so suppose I did x is equal to R norm, mean 5, standard deviation 6. And say how many numbers you want? I want a very large number. Say million numbers. So I have a million numbers. Or 10 million numbers. Billion numbers. Right?
If our RAM set is good, we can keep on adding. So it's bad, we can keep on deducting.
Yeah, I have a machine with an 8 GB RAM, so I can keep on doing what I want. Right?
Rounding.
Take a long time for your computer?
No. I'm copying the videos to our pen drive.
Right.
So 2 minutes.
Okay. So, thank you. I'll do them right away.
Yes.
That's why I left a little bit early.